This video is on problem 16.8. It is a situation here. The first step is to draw the picture, which they drew for you, and I put it up on the board here, obviously. And then label the picture really, really clearly. They give you all the numbers. They didn't label their own picture either because they just didn't get around to it, or it was too hard, or they wanted you to do it. That's probably the good way to do it. So, this wheel A, is a radius of 6 inches. I put those little slash marks there that mean inches. We just know that we're dealing with inches. This little tiny wheel is a radius of 1 inch. That's a 1 inch right there. And what we want is the radius of the D wheel, the medium-sized wheel there in the middle. That's what we're looking for. How big is that wheel? This one's got a radius of 7 inches. They tell us this one goes around at 20 RPMs. So omega A. Omega of the A wheel is 20 RPMs, and omega B is 42 RPMs. This one goes around 42 circles a minute, and this one goes around 20 circles a minute, 20 revolutions per minute. And now we got to figure out what the radius of that wheel is. Okay, so this is a puzzle. I love these problems. They're so much fun. You got to figure it out by knowing this thing, knowing that thing, putting all these things equal. Okay, first off, we want to find the radius in inches, so we don't have to deal with units. Okay, that's the really nice thing about this problem. As long as we use RPMs everywhere, and RPMs are a totally fine thing for this, we don't need radians or anything, we'll get a radius in inches, which we can change to feet if we want to, you know, but why do that? We'll just leave it as inches. Okay, so first, what we know is, if this thing here, okay, we know everything about this wheel and everything about this wheel. Then we can figure out the velocity. So we can call this VB here, the velocity on the outside wheel B. So wheel B. And we can call this one the velocity in the outside of wheel A. That's how fast these things are going, right? How fast this belt is going. I don't know what direction they're going in. Let's see if that one is going that way. This one's going this way, maybe. That way, turning the wheel, yep, I think that's right. Okay, so, and here's the cool thing. This is the major thing to know, okay? If the wheels are connected, they have the same omegas. Okay, so let's find omega C. We don't know what omega C is, but we know that it's equal to, I didn't leave enough room there. We know that omega C is equal to omega D because they're connected. They tell us those wheels are locked together, so they turn the same number of circles per minute, right? That makes sense. So, omega C is equal to omega D. And we know that the outside velocity of this wheel, since it's connected to a belt, has to be equal to the outside velocity of this wheel. And this wheel, VA, is the same as VC. Okay, so VB, another thing we know is VB, the velocity on the outside of this wheel, equals the velocity on the outside of wheel D because they're connected. They have to be going the same speed. So that equals VD. And we know that VA is equal to VC, velocity of the C wheel, because they're connected by a belt. The outsides have to be turning the same speed, right? That's how it works. Okay, knowing all those things, that solves the problem for us. Now we just have to do some things like figure out the velocity B, which we can figure it out because we have our formula that the velocity is r times omega, the radius times the omega here. Now, if we don't care about units, right, this really only works with units, but as long as we don't care about units, we'll be okay. Okay, so really this should be in radians if we want to get the velocity in meters per second, but we'll just keep everything in RPMs, and they're just off by a constant. It should work. You'll see how that works. Okay, so VB then, and some weird unit, VB is R7 times 42 times omega B, which is 42. Let's see, 7 times 40 is 280, 7 times 2 is 14, so 294. That's equal to 294. That means that VD is equal to the same thing. So VD is equal to 294, which is omega D RD. Omega D RD. But we don't know either of those, so we're kind of stuck with that. But we do know that. Okay, so now let's change gears. Let's use this one here. So velocity of A is equal to omega A times, which one? I was putting the R first. It doesn't matter which one. R omega. I'll just keep putting R first. So RA omega A, which is 6 times 20. So 6 times 20, which is equal to 120. That's how fast this wheel's going, at 120. And we know that's equal to this wheel. And we know its radius. It's 1 inch. That's awesome. So we can figure out that omega now. So let's look at omega C. So omega C, let's see, our formula equals R omega. So omega is equal to, put the R over here, V over R. Okay? So omega C of the little wheel, omega C, is equal to the velocity of C divided by the radius of C. Omega is V over R. Yep, that's right. Well, we know the velocity of C because it's the same as A, and we just figured that out, so that's 120. And we know the radius of C, they gave it to us, that's 1 inch, so we just divide that by 1, which is also then 120. Whoa, that's crazy because it's 1. Yeah, so it's 120. So omega C is 120. That, therefore, omega D is 120 because they're connected. They turn the same number of circles per second. How awesome is that? So I'm probably blocking all my work here, so now you can see it. Okay, so we know omega D is 120, and now we can use this formula to figure out the radius of D, because we have omega D RD is 294. So we're almost done here. So omega D RD is 294. So 294 equals omega D RD, but omega D is 120. So 294 equals 120 times the radius of D, and finally the radius of D is equal to what? 294 divided by 120? 294 divided by 120. They didn't make it easy math for us. So what's that? 294 divided by 120. I get 2.45. That could be worse. So 2.45, and that would be inches because the only radius we used was in inches. Okay, so this radius of this wheel here is 2.45 inches. 2.45 inches. Now, I don't know if they drew this picture to scale right. We can't say, yeah, it looks about right. They just randomly drew a picture. So we really can't say they drew that to scale. But it's a reasonable number, right? It's a reasonable number. So we could be relatively certain that we're right. Just be aware that these velocities are in weird units. If we wanted velocity in inches per second, we would have to change omega to radians. Right now it's in revolutions per minute, so it's weird units. Okay, well, hope that makes sense. And my phone's ringing. I gotta go answer it. Cool. Thanks for watching.